Okay, so in this video, we're going to look at sections 1.2 through 1.5 of your textbook, and following this video, we will have a couple example problems to go through for these sections. So let's go ahead and get started. So section 1.2, machines and mechanisms. So a machine is a device that's used to alter, transmit, and direct forces to accomplish a specific objective, while a mechanism is the mechanical portion of a machine that has the function of transferring motion and forces from a power source to an output. So, function of transferring motion and forces. Okay, so if we want to think about it, if we want to look at this height platform, right? So, what we can say is the entire device is the machine, and we can say that the mechanism is just the rigid parts. That actually produce the motion. So if we take a look, if we're looking at the mechanism, right, the mechanism is actually going to be what takes the power and the movement generated from the cylinder here and actually moves this platform. So the mechanism would actually be these linking bars that produce the motion. Okay, so synthesis is the process of developing a mechanism to satisfy a set of performance requirements. So when you're looking at a problem, you're going to get a set of performance requirements, right? The machine has to move this far, it has to move something this heavy, it has to do it within a time constraint, and that's what really you're going to be looking at with synthesis. And analysis ensures that the mechanism will exhibit the motion that will accomplish a set of requirements. So you're making sure that the mechanism actually produces what you want it to produce. Okay, so we're going to move on to section 1.3, kinematics. So kinematics deals with the way things move. It is the study of geometry and motion, and kinematic analysis involves the determination of position, displacement, rotation, speed, velocity, and acceleration of the mechanism. Right, the mechanism, again, being the mechanical portion of a machine that's function is transferring a motion and forces. So what are we looking at with kinematic analysis, right? If we're looking at this machine to the right again. So what we're looking at maybe is the length of the legs. We'll also be looking at how the legs are supported. So we're looking at, they have pins here, we're looking at how the legs actually connect to each other, this pin here connects these two legs. There's also a cross member here connecting this hydraulic actuator. We're going to look at how far the cylinder extends, because that parameter will judge, how far up and down this mechanism will move, and the machine will move, but we can also adjust the mechanism accordingly to get the proper output that we're looking for. We're going to also do something called dynamic force analysis. And what this is we're going to look at, aspects such as the force required by the cylinder to actually move the machine, right? And we're going to also maybe need to take into account, right, how much force are these legs going to feel. So we might have to look at the material needed. Okay. And really what this class is going to focus on is what is a planar mechanism. So the planar mechanism only moves in two directions. So in other words, their motion is limited to two-dimensional space. Most commercially produced mechanisms are planar, and that will be the focus of our studies in this class. Okay, moving on to section 1.4, we're going to look at some terminology. So a linkage is a mechanism where rigid parts are connected together to form a chain. The frame is typically a part that exhibits no motion and will serve as a frame of reference for the motion of all the other parts. Links are the individual parts of the mechanism. They are considered rigid bodies and are connected with other links to transmit motion forces. Now we know in the real world that rigid bodies might not necessarily exist, but we will treat many of these links as rigid bodies because for our purposes they do remain rigid. Joints are movable connections between links, and they allow relative motion between the links. Okay, so we're going to look at some types of joints now, and the first joint we're going to look at is a primary joint. So a primary joint allows only one type of movement. Okay, so we can see two examples. So this pin only allows rotation right here, and this slider will only be allowed to slide in this direction. So if we look at this pin again, A, it's also called a revolute pin or a hinge joint. And it only allows pure rotation. If we look at B, that sliding joint can also be called a piston joint, and it allows pure linear sliding. Okay, so let's look at higher order joints. So higher order joints, they allow both rotation and sliding between the two links that they connect. So we can see an example of one, right? This cam joint here, we can see that this link is allowed to slide here, and this cam also rotates. So now let's take a look at some of these links. So a simple link, right, shown on the left side here, only has two joints. So simple link is two joints. And we can see that this complex link here on the right has three joints in it, right? We have 1, 2, 3 joints. And so now we're going to look at actually how we can look and model a machine or a mechanism, how we'll actually take this and we'll model it so that it's easier to look at. So it's often difficult to visualize and analyze the movements of components in a full assembly. And pictorial representations can be complex, and it becomes difficult to focus on just the motion. So what we're going to do is we're going to break it down into basically the skeleton of the mechanism, and this stripped down sketch is called a kinematic diagram. So if we look at some of the links we just talked about, right? We have our simple link, and we can see that here, right? A bar with two slots where a pin can go through on the end, right? We can represent it this way. A simple link that has kind of this contour to it, we can represent as this triangle to get a better image. Complex link will also represent as a triangle, but we can see that we have 3 joints located here. And then we can see that another way to look at, right, this pin joint, we have the pin in the middle with the 2 links coming off of either side. We also can get a look at the slider, right? Easy enough to determine that this box will slide right here. Cam joint as well as a gear joint. So let's take a look at some of these special cases. So some mechanisms have 3 links that are connected at a common point. For kinematic analysis, this configuration must be mathematically modeled as 2 separate joints. So when we go through and we're making our kinematic diagram, we're going to label all the links and all the joints. Now, when we see something along these lines, we have to realize that in our analysis, we have to treat that as 2 joints. So we would label it along the lines of joint A and B being right here, not just joint A.